Rational exponents, radicals, and rationalization. If e over I is a rational number with I greater than or equal to 2, then we can write b raised to the e over I as a radical. One of those ways is the ith root of b to the e. Another way is we can take the ith root of b and then raise that all to the e. Here I stands for index, e for exponent, and b for base. First, we're going to convert the expression to radical notation. For our first example, consider x to the 2/5. So here, the 2 is the e, the exponent, the 5 is the index. So the 5 is the type of root that we have. So the 5th root, and the 2 becomes the exponent on the x. So the 5th root of x squared is the same thing as x to the 2/5. Now consider 5x squared plus 1 to the 1/2. So here, the index on the radical would be a 2, so we have a square root, and the power on the inside is a 1. So we have the square root of 5x squared plus 1, all raised to the 1. But this is not in simplest form. If we have something raised to the first power, there's no need to put parentheses. And a 2 on a radical is understood to be the square root, so the following is the correct way to write that. Now we're going to go in the other direction. We're going to convert the radical expressions to rational exponent notation. For our first example, consider the 6th root of y to the 5th. So y is our base, 6 is the index, and 5 is the exponent. So this is the same as y to the 5 over 6. And that 5/6 will not simplify, so y to the 5/6 is our answer. For our next example, consider the 7th root of 4x cubed plus x. Here, 4x cubed plus x is the base, so that's what's going to be raised to a rational exponent. The 7 is the index, and it's understood when there's no power specified that it's a power of 1. So this is the same thing as parentheses, 4x cubed plus x, close parentheses, raised to the 1 over 7. Now the parentheses is vital. If you do not put the parentheses around that base, it has a completely different meaning. Next, we're going to rationalize denominators and simplify the expression. For our first example, consider 4 over root 6. To rationalize the denominator, we multiply by the conjugate, and that just means that we change the sign of the second term. In this case, there's only one term in the bottom, so I will multiply the top and the bottom by root 6. So I have 4 root 6, and then root 6 times root 6 is 6. Now 4 in the top and 6 in the bottom will simplify to 2/3. So my final answer is 2 root 6 all over 3. Now consider 8 divided by 1 minus the square root of 5. Here, when I rationalize the denominator, I do have two terms. So I'm going to change the sign of the second term, and that will give me the conjugate. So I'm multiplying the top and bottom by 1 plus root 5. Now I want to be careful because a lot of the times something will simplify. So I'm only going to FOIL out or multiply out what I'm trying to rationalize, and then I'll see if something will simplify. So my top I'm going to leave as 8 times 1 plus root 5. In my denominator, I'm going to multiply 1 minus root 5 times 1 plus root 5. So 1 times 1 is 1. 1 times positive root 5 is plus root 5. Negative root 5 times 1 is negative root 5. And negative root 5 times root 5 is negative 5. So we see that the middle terms cancel, and that will always be the case because we multiplied by the conjugate. And 1 minus 5 is negative 4. So I have 8 times 1 plus root 5, all divided by negative 4. And 8 divided by negative 4 is a negative 2. So I can write this in two ways. One is negative 2 times 1 plus root 5. Or I could distribute the negative 2 through that parentheses and get negative 2 minus 2 root 5. Now we're going to rationalize the numerator and simplify the expression. So this time to get my conjugate, I look at the numerator. I see that I have root x plus 4 divided by x minus 16. So because I'm trying to rationalize the numerator, I change the sign of the second term. So I'm going to multiply top and bottom by root x minus 4. Now remember, I want to multiply out what I am trying to rationalize. So because I'm trying to rationalize the numerator, I'm going to FOIL that. So root x times root x gives me x. Negative 4 root x cancels positive 4 root x. And 4 times negative 4 gives me negative 16. So x minus 16 is my new numerator. The denominator is x minus 16 times root x minus 4. Notice that the x minus 16 in the top cancels the x minus 16 in the bottom, leaving me with 1 over root x minus 4. And that is my final answer.